Thanks, buddy. All right. I have very little confidence this mic is doing anything. Can people in the back hear me okay? Sweet. All right. I don't know anything about technology, so let's talk. This talk's title is The Social Coding Contract, but normally it's a 50-minute talk, so I had to shrink it down a little bit. So this is what you're seeing is the contracted edition. There's actually two versions of this talk. The longer one's up on the website. Actually, though, iCloud, because I don't know how to handle the iCloud conflict dialogue appropriately, this is the talk that you're getting. My name is Justin. I live and die on Twitter. If you want to be my friend, that's the first place to do it, although I'd love to meet you in person today. If you have any longer form feedback about the talk, you can reach me at hello@testdouble.com. So open source is good, right? Companies are working with other companies on common tools that they, for seemingly no reason, that competition wouldn't suggest they would do. Startups now, they have this mountain of open source, of free stuff that they can stand on. So if you want to build a new product, you just have to define this thin little new product idea on top, which is enabling all kinds of new businesses with very little capital. And never before has a single individual at a computer been able to independently change the world in the way that we can now when we push a new repo to GitHub. But is open source good, really? Because a lot of companies love consuming open source, but if you try to share a library, much less like an upstream patch, suddenly legal gets involved and they're really stingy about it. And a lot of the startups that I see hoover up a bunch of free stuff that they don't understand, and then they're creating maintainability nightmares a year or 2 years hence. And a lot of the maintainers I know, myself included, spend most of their time feeling a lot burnt out from the free work and the free tech support that we're offering the world on our nights and weekends. So today, my goal is to put a magnifying glass on just a handful of the systemic issues facing open source in the hopes that that becomes a thing we get in the habit of doing. And maybe we'll gain a sense of collective, understanding that there are problems here. And only then could we hope to have some new ideas that might lead to creative solutions to address these problems, and ultimately a state of relief, and then we're done. But this is a very modest talk. I'm only going to focus on problems. It's kind of like I'll point out a few times, please fix this. I welcome solutions. First thing I'm going to talk about is the teetering Jenga tower of dependencies that we all stand on in modern application development. And then I'm going to pull the curtain back a little bit and talk about what it's like to be an open source maintainer. I'm going to talk a little bit about trust and marketing, and then some deep thoughts about how we interact with each other in open source, as well as where I think things are going to go in the future. I like to start off talks with the term definition. So the term ideology came to mind when I started working on this. A lot of people think of the word ideology as like a political affiliation, but I like this quote better. They do not know it, but they are doing it. That's a definition of ideology that defines it as sort of this negative space, the subconscious that drives our actions without us even realizing it. And that's a quote from a dude named Karl Marx. It came from his book Capital, which is an interesting book because it existed at the intersection of philosophy and economics. And the reason I chose that quote is because so does open source, right? We have sort of this altruistic vision of everyone writing stuff for free for other people. But meanwhile, there's all these companies making buckets and buckets of money off of open source too. And we tend not to really consider that intersection very much. So upon reflection, you might look at economic progress over time and then compare that to what open source's progress has been like. In the beginning, every person was out on their own, subsisting by themselves, just trying to get by. But eventually, groups of humans came together, and they formed specialization. So I could go to one person for my vegetables, another person for my meat, and through the scaling efficiency, recreation, art, they emerged as well, and human culture started developing. Industrialization, now I can go to one place and get all of the commodities that I need each week, freeing up more and more time for more and more activity. And now, from my bed, on my iPad, I can one-click everything that I need in the week and have it shipped directly to my door, enabling my laziness. This is progress. But where does it lead? I think there's a very valid question that was raised by rumors last year that Amazon is actually using big data to predict what you're going to order before you order it, and then pre-shipping it to the distribution center closest to you, so that when you click it, they could do same-day and next-day delivery. And this is fundamentally turning on the head the traditional, relationship that we have with humans engaging in commerce. So that's an example of an unintended consequence. Another unintended consequence of industrialization was examined in the documentary Food, Inc., which I don't know about here, but in the States was very, very popular, and it has this ostentatious tagline, "You'll never look at dinner the same way." But I feel like it would be more honest if the tagline said, "For at least a month," because it's a systemic issue. right? We all understand that as we make progress in any direction unilaterally, awfulness just kind of accretes up until it gets to the point that everyone freaks out about it. But these are really, really big systems, and they can't turn on a dime. If you try to make it better, it's always going to get a little bit worse first, and your best hope is just to bend the curve. So I feel like we're at this point in some areas in open source now. And so when you dive in, the first thing I want to talk about is dependencies, the tools that we use to get dependencies in, as well as the tools that we use to publish dependencies to share with the world. So if you chart open source's progress over time, it's a little bit analogous. In the beginning, we just had files. Like if you were doing C code in the 70s, 80s, you just had headers and C files. And I remember projects where literally like I had some of my own code, and then I'd find some listing on the internet, I'd suck it down, I'd depend on it, and then I would logically that became part of my application moving forward. It wasn't versioned, and it was a hedge against pulling in too much because I knew that it was my problem if it broke or it needed to be updated. Makefiles were a really big, and dynamic linking were a really big innovation, because now I have my application, but I have sort of this dotted line here to indicate like I'm depending on this thing, but it's a separate tarball with its own build process, it's versioned separately, and then it's linked at runtime. So my application started to emerge as this thing that I owned, and my dependencies were apart from me. Java, I think, pushed this even further because jar files, the Java bytecode was portable. And so I could go to a website and download a jar file, stick it on my class path, and it was convenient enough that a new meme emerged called transitive dependencies. At least from the perspective of application developers, this was new. Both of these dependencies, they might say, oh, and by the way, we depend on this third thing. It may be like Creative Commons. And what that enabled was each of the dependencies we started pulling in were getting smaller and smaller and more focused, which allowed us to suck in more of them. In fact, one of the cool things about a lot of those like transitive dependencies in the early goings was that new language stacks, like alternative language stacks, started emerging within a single vendored language ecosystem for the first time. Like the Creative Commons stack was a very different style of Java from what Oracle Sun wanted you to do. Ruby took a lot of this and just automated it for us. So Bundler was a very successful project insofar as I can just, in a gem file now, declare the dependencies that I want in my application, and then I don't have to worry about the transitive stuff because it does all the version resolution for me, it finds all the transitive dependencies, and now I can have dependency graphs of arbitrary depth without necessarily worrying about how much stuff I'm standing on top of. And NPM was able to take this even further in Node.js, right? Because Node has no process restriction. It can multi-load multiple versions of the same library in multiple places and different depths in the tree. So a trivial implementation of NPM might be able to say, like, I can depend on these things, and then I'll just recursively search for all the dependencies of all the dependencies until we get to very, very deep graphs. And so it's not unusual at all for, like, as a library maintainer to start getting support tickets opened against me, saying, hey, this library literally brushes up against the Windows max file path limit of 256 characters. And this has happened on like multiple libraries that I've written, and all I have to say is, sorry, I don't use Windows, and then move on. What this progress has afforded us is short-term progress, short-term convenience, and it's available to us for the low, low price of long-term fragility. And we don't think about that much, but the comedian Louis C.K. recently talked about this phenomenon. Oh, shoot, let's go.
Makes you happy is going to end at some point, and nothing good ends well. It's like if you buy a puppy, you're bringing it home to your family saying, hey, look, everyone, we're all going to cry soon. Look at what I brought home. I brought home us crying in a few years.
It seemed to resonate with me anyway. So there's a fellow in the Ruby community named Gary Bernhardt. He's kind of like our Louis C.K. And he had a great quote that I really appreciated. It said, build a small but non-trivial Rails app. Now, an empty app will have 50 gem dependencies, but yours will have 75 to 100. Now go away for 6 months and update all your dependencies. Your app no longer works. This is true 100% of the time. It's not usually true. This is always true in practice. And I found it to be true when I try to update all my Node modules as well. But it's easy to start. It's easy to start a Jekyll blog. It's easy to install Sass. It's easy to generate a new Rails app. It's always easy right now, never in a year. We're going to talk a little bit more about why that is, but in some specifics about how we approach our projects, one of the prerequisite bits to understand is that when we talk about our applications at work, we usually are only talking about the code that we write as being our application. But if we upon any sort of trivial amount of introspection, we of course will understand that whatever it is we're shipping into production is our application, even the invisible bits that we're depending on. So yes, it's true, it's never been easier to write a new application, but the stuff that we're shipping as version 1.0 into production has never been more complex. A couple of the things in Node that have tripped me up over time is as writing a library, I can depend on, say, version C of Orange Triangle, and one of my dependencies could depend on version B of Orange Triangle, and one of its dependencies can depend on version A of Orange Triangle. And it raises the question, if I invoke the function that I directly depend on and get the return value, and then foolishly, admittedly, but this happens sometimes with some dependencies, pass that into my dependency, which passes it in here, as a library maintainer, how often am I thinking like, testing that somebody's going to be using multiple versions of my function simultaneously and passing data between them? Probably not. So the question as a user is, will this blow up or will it work? And the answer is nobody knows, which isn't really good from the perspective of stability of an application. Another problem that comes up, especially in library development, is say Orange Triangle has a very loose dependency on red square at version star, which means that the time that your user installs, they'll just get the latest and greatest version, no matter what. And there's nothing that I can do to fix that transitive dependencies version. So one day on our project lineman.js, we started getting tickets. It was like March 12th or something, and every new install started failing. So what we found was that red square had become somehow incompatible with Orange Triangle at some newer version. And so the only tool that we had available, because that dependency wasn't being maintained anymore, was to recognize what was breaking, fork it, push up set the version explicitly to the one we knew worked, and then push that up to NPM, and now we have this additional dependency we don't really understand, that we own, that we're saddled with maintaining, and we really aren't going to do a good job maintaining. And this has happened multiple times now. So even though NPM is very convenient, things aren't perfect, and there are a lot of edge cases that come with just juggling this many dependencies. When I think about it, I obviously understand the code that I'm writing in my application is code that needs to exist. And I even understand that the stuff that I depend on is there for convenience. It helps me do my job more efficiently. And I'm even willing to admit that the stuff it depends on is a necessary complexity. But my brain never goes any deeper in the stack of dependencies than that. If I think about any lower, it just starts to feel risky to me. And when was the last time you asked about any of your transitive dependencies? It just starts to feel mysterious over time. So looking at this big march of progress of open source tooling, yes, make files were a huge pain in the ass, but maybe that was a healthy pain. It helped as a guard against pulling in too much stuff that we didn't understand. And I think going forward, it's not like we're going to put the genie back in the bottle, but we have to take a much deeper look at the ramifications of not understanding the stuff that we're shipping. So I want to talk a little bit about the human side of what it's like to be a maintainer. The most important thing to keep in mind, open source maintainers are just humans. They are not rock stars. In fact, I like to think of maintainers and being a maintainer myself as being just like an extra early adopter. Because honestly, here's how I become a maintainer. So a maintainer goes to Google, they search for some tool that they need to exist, and then no results are found. And they're like, OK, cool. Well, I guess I'll go turn around and build this thing. A slightly less early adopter maybe comes by the very next day, searches for the very same thing, and sees the thing that the maintainer just built. And the symbiotic relation here starts off usually with Hacker News. They might jump up and sort of like when you're excited about an indie rock band or something, you want to go tell everyone about it. And immediately the maintainer gets stars in their eyes, right? Because they're getting some accolade for their work. But early adopters, especially on Hacker News, are assholes, so they're very quick to point out all the things you don't do correctly. But remember, too, that early adopters are usually just as competent as maintainers, and so very often they'll go ahead and send pull requests that fix those things. And now the maintainer's happy again. What I found as a maintainer going through the cycle many times is my ego gets really wrapped up in all of my projects in an unhealthy way. If you think about the very first release of any project, it's usually just there to scratch the maintainer's itch, solve some immediate problem for them, so it's going to have some rough edges. And those early adopters are great with those initial pull requests because they help smooth the whole thing out. So then, if you look at that smoothed out version, maybe that's your version 1.0 because now it's ready for consumption by the masses. Or if you're like me and you're afraid of the implications of semantic versioning, maybe that's your version 0.84.0, which is where most of my modules are sitting. So at this point, this is the conversation I wish happened between maintainers and early adopters. A maintainer should say, hey, let's own this together. You've contributed. That's great. And most early adopters would be thrilled to hear that. Or I'd even settle for like, hey, let's make you a committer, and the early adopter could come in, be part of the community, triage issues, and help out. But because those conversations don't happen, the conversation that may as well happen is, hey, let's never communicate again. And then the early adopter is just, okay, and off to the next thing, and we never see them again. So I often ask myself, like, why don't maintainers just share control more readily? Why is it only really experienced open source developers that tend to be very aggressive about sharing control early? And I think it's because they mispredict, they misjudge how much happiness open source projects are going to bring them. Because if you chart happiness over time, they start off happy. They built a thing for themselves that worked great, and then they got positive attention for it, and then they got to version 1.0, and so they just extrapolate that line, and they think, this is only going to bring me more and more happiness forever. But that's not how it works, because late adopters will disabuse them of this happiness. The way that late adopters typically work, they come to projects after like things have usually settled down a bit. Like as a maintainer, remember, I'm like an early adopter too. I might go 0 commits for a week or a month because to me, it's a solved problem. Some new problem's going to come along and distract me and gain my attention, and I'm going to go run off and do that. But a late adopter might come to the project weeks, months, years later, look at it and say, oh, look, no recent commits. That's good from my perspective because that sounds stable. 800 stars, that sounds safe. And of course, open source sounds free. That's better than a proprietary solution. And so for a lot of business users, they come to it with a just very different mindset. So for everyone other than the maintainer and the early adopters' needs, if you kind of view each dependency out there as being a well-understood little set of responsibility, every new subsequent user after that brings their own baggage. They bring their own needs, and they're never perfectly aligned with whatever that dependency does, which means that everything in that unshaded area is a negotiation. It means that those late adopters have to decide, do I open a pull request? Do I work around this? Do I just complain via an issue? And they tend to be a little bit less eager to contribute than early adopters are. So usually I just get complaints. So it's not uncommon at all for like 2 days later, and the late adopter will come, put a stern look on their face, say something like, what? This doesn't enterprise my enterprise thing at all. And how could they ignore something so important? Because from their perspective, it is. So this is where entitled GitHub issue threads come from. Missing obvious important feature. We thought this was a good thing, but it doesn't do all this silly nonsense. And I try to be polite. I reply, oh, I'm sorry, I didn't know that it needed to do silly nonsense. Can you explain why this is important? And instead of a nuanced conversation, this is the point where all of their coworkers just drive by +1, to try to pressure me. And the subtext is that I let down these strangers on the internet, and I should feel bad and do free work for them. At least that's how I interpret it, because I'm probably at the park with my beautiful wife over there and having a nice, wonderful, relaxing day. But instead, I'm just glued to my phone, feeling like I let down these strangers. So I get in the car and I drive home and I hack, and I work on whatever it is that they wanted. And then, come back to the thread and say, hey, look, I just spent all weekend on this. Can you verify that it works? And of course, what happens at this stage is I never see them again. And so now I'm sad because I just took a thing I loved and then responding to, some angry strangers made it appreciably worse, doing work for free, and it's something that I'm gonna have to maintain as an edge case in my system, going forward. So it doesn't take long, it doesn't take very many instances of this for me to eventually just grow to get less happiness from my system than I got when I started. If you wanna look at my GitHub repositories and adopt any of it, please do, because I hate almost everything that I've ever published because of this process. Trolls are another aspect that don't affect everybody but are significant. Remember, open source maintainers not being rock stars means that they're just people, but we often don't treat them that way because they have this asymmetric power. They might have lots of followers on Twitter or lots of notoriety. They might speak up at conferences like this one, but I think that even if, we'd admit that if you have 15,000 followers, there's probably a couple trolls, okay, sure. But because the asymmetric nature of Twitter and all the communication we live in, you might not see that those trolls have an outsized influence in the sort of the proportion of communication that maintainer receives. So when a maintainer disappears, and everyone's surprised, what? Everyone loves him. I don't understand. I think this is a big reason why. A good example, if you want to read about this, Seth Vargo left Chef, the company where he worked, got to work on open source for his job, and he was really good, and he loved it, and he had a lot of people love him. But a few trolls were able to steal all the joy from that for him. So yeah, trolls, further decreasing happiness. And this is normally where the calls for help come. Like, hey, I'm burned out, can somebody help me? Hello, anybody. But this is so late in the curve that this isn't the sexy, new, attractive, exciting project that it used to be. It's now saddled with all this stuff that nobody wants, and it's old, and there's just, those early adopters aren't there to convince anymore to pull back in. And so that's exactly how most projects die. So the takeaway here is that open source projects tend to only survive when communities grow alongside them. And maintainers need to feel comfortable being able to say no to people. Maybe this isn't the best fit for you. Let's talk a little bit about trust and marketing. So open source would be nothing if people weren't consuming it, if people weren't adopting it. And the way that people tend to adopt new dependencies is that they trust that it's going to do the job well and be reliable and not cause any pain. When we talk about trust in open source, though, there's this explicit trust. They're the things that we list in our package.json file that we know that we're relying on. But we don't very much talk about the implicit trust. So just keep in the back of your mind, like, you're not only trusting the person that did their job, but you're also trusting all the people that they trusted into this very deep web. So the question of how do we get people to trust us is pretty obvious. The answer is marketing. And if we look at marketing over time in the history of open source, consider Linus Torvalds' 1991 announcement of the Linux operating system. He posted this to the Minix user group. I'm sure it's a perfectly nice email, but I want to highlight a few things. One, he had no catchy name for the thing. He made a self-deprecating remark in the first sentence. And then at the very end, he went off message and talked about how it would only work on this one particular hard disk. This is bad marketing. So if Linux were released today, it wouldn't have even made the front page of Hacker News, and yet this is the thing that runs most of the servers in the world. And so I think that should give us pause about just sort of how things are changing in terms of open source and how it's marketed to us. About 10 years later, the Apache Ant project had a big website. This is a Java build tool. And they spent the time building a logo. Look at all this website stuff. This is a ridiculous, they had a mission statement. One of those links is a mission statement. They had foundation affiliation. All of this was trying to confer trust because open source wasn't really well regarded in enterprise yet. And they're like, you can trust us. This is safe. Consume me. But we don't have that kind of time anymore. We don't have that much time to vet each and every dependency. I don't care about your mission statement. Nowadays, we have the canonical, GitHub Markdown README file. And what we look for here is very often, a quick introduction, some easy steps showing me exactly how to use the thing and plug it into my app, and then some mostly green badges up at top to show me that things are mostly working. And that's all I need, and then I suck it in. And it's really become an arms race, especially as we start to see like corporate-sponsored open source projects from like Facebook and Google and so forth. This one's from Google. You might be familiar with Yeoman. Yeoman is a project where a diverse group of engineers work on a rocket ship. And you can see here, it's got gradients. It's got a really authoritative tagline. It has this one-liner that you run, and then it just does everything for you and walks you through a tutorial. It can generate 1,000 different types of projects, which is a terrible idea. But it's super popular because it's marketed really well. All of these things are optimized for adoption. We've oriented our community around it. Even the fact that we treat them like rock stars, but really visible people in the community. Like I think we got Substack here. When I see one of Substack's node modules, I'm like, okay, well, I know he's smart. I know he probably did a good job, and he'll stand by it and pull in other maintainers, so this is probably safe. I might look at how many stars or how many forks a particular library has. I might look at the GitHub Pulse to see how quickly they close stuff and how on top of maintaining things they are. A lot of people look at downloads, even though it's a totally arbitrary number. If we see something with a lot of downloads next to something with not very many downloads, we might confer a little bit of trust. And then semantic versioning, I think, is interesting because we managed to survive as a species for 50 years with no real formal, rigorous versioning standard. So why is it in the last 2 or 3 years that suddenly this has become the most important thing? The answer is we have so many dependencies now that at a glance we need to know, is this safe to use and is this safe to upgrade? Really quickly at a glance. So all of that to say, that's just the explicit trust. That has nothing to do with all the implicit trust that we give to transitive dependencies. Nobody's vetting that stuff. So the takeaways here, I just recommend you to understand that the more people you trust, the more people you don't even realize that you're trusting in your application when you do suck in a lot of dependencies. And also recognize when you're being marketed to. Marketing is neither good nor bad. I engage in marketing all the time. I'm here, talking to you and trying to sell you on my particular brand of things. But if you don't understand when you're being marketed to, it's very easy to be led by the nose, led astray, and oscillate between different things without really being anchored. Let's talk a little bit about how we engage together and some other thoughts about the future. First of all these stick figures that I showed you were unfortunately a lie, because what they convey is that open source is a thing that happens between humans in real life, and of course that's not true. How we actually communicate, email, GitHub issues, Twitter, all of that's just asynchronous text, and that means for most intents and purposes, we're no more than an avatar, a username, maybe some emoji once in a while, and text on a screen. Evie had this great quote. It's effed up that a lot of modern discourse is optimized for whoever has the fewest feelings and the most free time. But that's exactly how all of this asynchronous communication is built. So what I'd recommend is when there's uncertainty between people or ambiguity or disagreement, or even if it boils up to the point of simmering disdain, maybe asynchronous text isn't the best communication medium. What I try to do whenever I have any sort of conflict in open source or in work or working remotely is I try to bubble up to the next higher level of fidelity. So if asynchronous text isn't working, I might try real-time chat. And if I'm not able to convey emotion well there, then I might try a voice call. And if I'm making somebody cry, I can see it with a video call. And if all else fails, we can, the world's only so big, but there's a lot of conferences, maybe we can find a way to meet up in person. Normally when you lock people in a room, they come out with a much higher degree of understanding and camaraderie than they do when they argue over Twitter. Shock. Also, this strategy can be great troll repellent. So if trolls are something that you worry about, remember that trolls get their power through anonymity and a perceived lack of consequences. So if somebody's trolling you and you say, hey, let's just talk about this in a Google Hangout, suddenly they disappear. Pro tip. So what I'd love to do is if our tooling would encourage that escalation of communication. In a GitHub issue, it would be really cool instead of just being able to comment with text to be able to say, hey, I'd love to start a chat with Gitter, or build a live example in line with JS bin, or schedule a pairing session or just start one with Screen Hero or on my Nitrous IO box. Tools should encourage us to engage in higher order communication with one another, because that's where we will resolve conflict more easily. So a little bit about what I think the future holds. I told you that things were awful, right, that we're here, and then I said that things are going to get worse. So it's only fair to ask what's going to happen at the apex and how might that curve get bent. It all started when I saw Yehuda quoted at Gogaruko saying about the Rust programming language that Rust enables a whole new generation of high-level programmers to write systems-level code. And I thought I was going to quote him here to say, that's terrible, because look at how we're ruining high-level code with this huge culture of dependency. But slowly, I became OK with it, because I think that it might contribute back, and I want to show how. So if you chart innovation over time, obviously in the early days, there have to be low-level systems to build high-level systems, so most of the innovation that was happening in open source was in low-level systems technologies. But slowly they crept up over time until the bulk of what we know as open source in the last 15 years have happened exclusively in service of the web. And only recently are we going back down to basics with Go and Rust and those ecosystems, building a lot of the same tools down from what we understand as best practice for web development. So if that's today's dependency culture, a fear is how will it translate? If we just cargo cult this, how will it work? One of the key differentiators between high-level systems and low-level systems is that embedded real-time failures tend to have very grave concerns. I mean, ask yourself, what's the worst thing that could happen if your website fails? And in the US, it was Obama's healthcare.gov. It started spitting out errors, and for 60 days, people couldn't sign up for healthcare insurance. And that was really rough, but I don't think anyone died as a direct result of that. But with a low-level system, you could have something like the Da Vinci machine operating on the table, and if this thing fails, you die. So fault tolerance is a completely different discussion between these two groups. When I talk to my systems engineering friends, they typically talk about how adopting a dependency outsources our understanding of that task. They kind of view it as their application has a certain set of responsibilities, and when they overlap that with a dependency, everything in that shaded area becomes what I call understanding debt. It's stuff that we know what it's doing, but we don't necessarily know how it's doing its job. And that's perfectly OK if you're able to iterate. Because if you iterate on it, you can understand oh, this is resource intensive, or oh, this is slow, or oh, this API is kind of crusty. But if for whatever reason you're not able to iterate regularly, then it's probably not very wise to outsource a lot of your understanding to these third-party dependencies. And that's why they're not in the habit of doing it. Because if you compare hosted systems versus embedded systems, some hosted website is centralized. An embedded system is usually fabricated and shipped out the door. Hosted systems tend to live a short lifespan. Embedded systems might be rated for 30, 40 years. Hosted systems tend to have like an ongoing staff. The people who built it are supporting it over the course of its life. Embedded systems might just have an RMA process. Hosted systems usually have more than enough in terms of CPU and memory resources, but embedded systems often have to calculate their overheads. Hosted systems are highly connected, easy to patch, continuous delivery, and a lot of embedded systems will never connect to the internet again. That's why, when shell shock occurred last year, it was like, oh shoot, my smart fridge is just forever, at the mercy of this particular bash exploit because it'll never upgrade itself. So it's easy to update, easy to iterate in hosted systems, and harder to update and iterate in embedded systems. So all that to say that systems engineering requires a deeper upfront understanding of what we're building. If we compare like a web application versus maybe some like landing gear component, if we think about how much we have to understand to write a web application, it's really just a thin layer about HTTP lifecycle. Like, you could learn it in a couple weeks. But you might have to know a great deal about how that landing gear component is going to interface with other bits of hardware and have a much deeper understanding of the context. So if we take like what's become a very common pattern of writing just a thin layer of models on top of like a mountain of dependencies, and we cargo cult that over, we're left with this danger gap of understanding that our application should have if it's going to be responsible, but doesn't. So a lot of my embedded friends, what they do is they just write more code and they depend on less code. Or if they pull in a dependency, they go through a process called tool qualification and they actually prove rigorously that the dependency does what it's supposed to do. They have a completely different mindset. So remember that all of our tooling, our understanding of like what it's like to like npm install something is basically fueled by the web development that we're all familiar with. And my hope now when I think about this is that if this is today's perspective and Rust and Go kind of build similar ecosystems down at a low level, maybe we'll feed back some of that cautiousness, some of that understanding back to web development so that we can be a little bit more rigorous in understanding the mountain of stuff that we're standing on. So we covered a lot of ground real quickly. We talked about dependencies. We talked about what it's like to be a maintainer. We talked about marketing. We talked about where I think things are going. And I don't mean to be a total sourpuss. I don't mean to be really negative. I think open source can be a lot better. Working with our companies and just encouraging them to understand that contribution to open source is a terrific risk mitigation strategy. Like whether that's looking for bugs or auditing for security, it can be really fantastic to just understand the things that you already have on your plate. For startups, a lot of times trying to caution startups to understand that they don't understand the things that they're pulling in. And that means that they either have to level up and understand all the open source that they depend on a little bit better, or if they don't have the time, if they have to ship out the door in 30 days, 60 days, understand that version 2 of the application would probably be better off as a full-blown rewrite. I like to call that the slow code movement, which is an excuse to use turtle emoji. And for maintainers, I found that I have a lot more joy when I pull in other maintainers early on. And I found that a lot of developers who don't engage in open source are able to have a lot more fun by just literally volunteering, reaching out to an open source maintainer and asking, is there anything I can take off your plate? And only by sharing this burden a little bit, instead of expecting free work from a select few individuals on nights and weekends for presumably karma points, are we really going to get past it. So anyway, my name's Justin. It was a pleasure speaking with you today. Test Double is, as Richie mentioned, it's an agency. And we do consulting work around the world for different clients. So if your team needs really great developers working alongside you, please get a hold of me because we're always looking for new clients. Also, I've got stickers. That might interest you more, I don't know. So if you'd like a sticker or a business card, just find me all day. I got a little baggie of them. But it's been an absolute pleasure. Thank you for your time.